My name is Professor Patrick Hall. I was born in California to Canadian parents, studied undergraduate astronomy at University of California, Berkeley, graduate astronomy at Arizona, and then did postdocs at the University of Toronto, Universidad Católica de Chile, and Princeton University before showing up here to York as a professor in 2004. I am a scientist today because of science fiction. As a teenager, I read my dad's monthly science fiction magazine, Analog, which every month had a science fact article. And once I read an article on subatomic particles, I was hooked, on physics, that is. And in a university, I found that astrophysics was, to me, the most interesting branch of physics. And so I've been an astronomer ever since. Right now, I study supermassive black holes. So if you imagine zooming out from our Milky Way galaxy, all the way beyond the galaxy and looking back, you'll see about 100 billion stars and giant clouds of molecules that are slowly collapsing to form new stars. And everywhere else you look, you'll see tiny points of light that aren't stars, but entire distant galaxies. And if you zoom in to any of those galaxies, as long as it's big enough, it'll have a giant black hole at its center with a mass of millions or even billions of times the mass of our sun. If you could watch one of those galaxies while a gas cloud got too close to the black hole, you would see the gas cloud get torn apart to form a disk of gas spinning around the black hole at a tremendous speed and gradually spiraling in to feed or accrete onto the black hole. Now, the gas is moving so fast that friction heats it up to a temperature hotter than the surface of the sun over an area millions of times greater than the sun. So that puts out so much light, we can see these objects across the universe, and we call them quasars. And occasionally, this turbulent disk of gas tosses up a clump of gas that gets pushed outwards by ultraviolet light and forms a streamer of gas racing out into the galaxy surrounding the quasar. And when that gas flowing outwards hits gas coming inwards, it can bring it to a halt and shut down the gas spiraling into the accretion disk and basically turn off the quasar. The gas can even shut down star formation in the galaxy by shock heating all the remaining gas in the galaxy. The galaxy stops forming stars, and its future appearance is very different than its appearance before the quasar turned on. So my collaborators and students and I are studying quasars in order to understand galaxy formation better, and just because quasars are cool. Thanks.